Okay, this is our review of solving linear equations. I'm just going to do one problem, that way the video is a little bit shorter. And also, if you notice, I put steps out to the side. A couple of you talked to me about how you thought it would be easier and you think in steps. So I went ahead and put that there, and hopefully that'll help some of you as you are watching the videos. Okay, so we're again solving linears, and the reason why that we know this is linear is because it has just single x's in it. There's the bell. It does not have things like an x squared in it, nor does it have anything like an absolute value of an x. Just plain x's, even though there's a lot of them, they're all just plain x's. So this is a simple linear equation. We should get one answer out of this. All right, so step one over there is to simplify each side of the equation, and that means you should be doing any distributing that needs to be done and any combining like terms, but only if they're on the same side. So I'm just going to focus on one side at a time, simplify it as much as possible. So on the left, I need to distribute that -3. So I will have my 8x stays the same. -3 times 5 is -15. -3 times -x is positive 3x. And then I'm not quite simplified because I still have like terms. Those are linear terms that need to be combined. Things with x's are linear terms. 8x and 3x makes 11x. And we still have our -15. All right. Then let's work on that right side of the equation. So on the right side, we also have distributing to take care of. Here and there. So on the first one, we're going to distribute the 4. 4 to the x makes 4x. 4 times -5 is a -20. And then now distributing the +3. +3 to 3x is a 9x, and +3 to the 1 makes a +3. And we have like terms. We have linear terms to combine. 4x's and 9x's is 13x's. And then these guys, the name for those are constants. If we combine our constant terms, we have a -17. All right, so step one, done. We have simplified both sides. We still have like terms. There are still linear terms in multiple places, and there are still constants in multiple places, but they are not on the same side. That's why we're moving past step one. All right, step two says to get all linear terms on one side of the equals. So we have two choices. We could choose to take the 11x and subtract it over from the 13x, or you could choose to take the 13x and subtract it, since they're both positive, that's why we're subtracting. Subtract it to the 11x. I don't care which way you move. That's why I didn't specify in step two which side of the equation to put the linears on. I like to keep my results positive, so I'm going to subtract the 11x from both sides. That way my result is a positive on the right. So on the left, that will cancel, and we will have -15 left. We have 2x's here, and we still have our -17. So we have successfully done step two. Linear terms are together on the same side. Now we're ready to get our constants onto the same side. So actually get our constants onto the other side. So I have moved my x's to the right side of the equation. So I want to move my constants to the left side of the equation. So I need to move that 17, that -17, by adding it to the left. And that would result in, let's see, it cancels there. That would result in a +2 equaling 2x. All right, step three is done. We have gotten our constants on one side. And the last thing is you may have to do one more step to isolate x. In this case, to get x by itself, we have to undo the multiply by 2, so divide that 2 away. And we are left with 2 divided by 2 is just a single x. 2 divided by 2 is, again, 1. All right. So 4 steps. Oh, done. Check 4. Simplify each side. Get all the linear terms to one side. Get all the constants to the other. One quick note. All of these red steps where you are moving things from side to side, you don't have to show me that in your work. You could just show me the resulting equation. but I know a lot of you like to show it. It helps you stay organized. All right, so we've solved the equation. We got that the equation will only be true if x is 1. So there's only one way to make this equation true. Now, I did leave out one important step out of our 4-step process. You should be able to check your answer and see if you are correct. So, here's our equation again. I do expect you to be able to plug and chug, so I'm going to do that real quick just to make sure everybody's comfortable with that. I like to split down my equals so I can think one side at a time. All right, we got that. X was 1. Only when x is 1 is this equation going to be true. So let's plug it in and see. Using parentheses when we plug in 1. All right, on that left side then, let's do some order of operations. If you have forgotten, order of operations is, please excuse my dear Aunt Sally. So parentheses first, inside of parentheses. So that's here. We'll need to simplify that. 5 minus 1 is 4. Keep everything else the same. We do not have any exponents. That's the e. So we're ready to move on to multiplying and dividing. We do have that. 8 times 1 is 8. Negative 3 times 4 is negative 12. All right, and now we can finally move on to adding and subtracting. 8 minus 12 is negative 4. All right, so when we plug in 1 to the left, we get negative 4. Let's cross our fingers that when we plug in 1 to the right, we also get negative 4. So plugging in 1, we use a little parentheses. There we go, okay. Order of operations says work inside of parentheses. So here, 1 minus 5 is negative 4. And on this guy, we're gonna have to do this kind of 2 steps. 3 times 1 is 3 plus 1. So really inside of there, we're getting a 4 inside of there. And we still have the 3. Okay, let's see, now multiplying. So negative 16 plus 12. Now we're ready for our adding, negative 4. So it works, we've done everything right. We know that when x is 1, the equation is true. Okay, that's solving linears in a nutshell. We will do more practice with this in our station work tomorrow.